Hello, everyone. Hey, Vikram. Welcome to the show. For the folks who do not know, Vikram is the creator of AX-LLM, which is a TypeScript port of DSPY. It is hands down the most comprehensive of all DSPY ports out there, to the best of my knowledge. And the sheer velocity and the work Vikram has been doing. So it's fantastic to have him as the guy inaugurating the first episode of the DSPY weekly podcast. Vikram, welcome to the show.
Hi, thanks. And I did not know this is the first episode, so thanks for having me. Guess makes it that much cooler.
Absolutely. Hopefully, we'll do a episode 100 and get you back if this goes
All
well.
right.
So, Vikram, we'd love to know, a little bit about you, what you do, where you're based out of, and what was your inspiration behind taking up this mammoth effort of creating a port in TypeScript for DSPy?
So I've had a long journey in general. In short, I've always done startups, except for a short stint when I sort of joined LinkedIn back in like 2010, and I built a lot of the early ad serving infrastructure and stuff like that. A lot of like in backend infra stuff. But then after that, I came back to startups. Essentially, around the time I was back in startups, there was like not a lot happening, and I was it was like I didn't really want to go back to like APIs and stuff, and I don't want to get into the crypto stuff either. So I was sort of like trying to figure out where things are heading, and I was experimenting with the startup idea I had. I was like I spent a lot of time on Archive. It's this thing that it was getting really popular then. So I built this thing that sort of had the social layer, sort of like LinkedIn on top of Archive. You could see who, based on like your Twitter graph and stuff, you would see like relevant content and like papers. And the idea was I was not trying to like just list papers like a lot of sites do or whatever. I was trying to like extract the valuable information from inside the paper and then sort of highlight it in a relevant feed. So you're not going to see bio papers if you don't care about it.
Got it.
And it was like insights more, and I wanted to like make them very customized for you. So and the problem with that was that I had this whole idea where I'll incentivize all these people to try to look at like use crowdsourcing and all of that, and had this whole thing going. And I started to like and obviously that was like that's a huge thing unto itself, and it's kind of hard and all of that. At the same time, I started to like sort of explore. Like I had a lot of experience with ML at LinkedIn, but essentially that's more like linear stuff, linear regression, logistic regression stuff.
Got it.
And obviously you couldn't do any of this stuff. And so I was like still trying to figure out, maybe I could classify, the simple stuff. And I started getting hints of new things that were like, as I started digging further in, I saw things like BERT models and some of these, so like these, word2vec and some of this stuff. And obviously I was like alien to me. Word2vec, maybe not. Some of this BERT early transformer models and, some of that stuff. I'd say way longer than 3 years ago. I would say even like 5-7 years, maybe 2017, 18, if I remember right. So I started to like dig into them, and I was pretty surprised. These were like not big models, but like you could take the abstract of a paper and get like summarized points, and you could like do named entity extraction, classification. You could do basic summarization.
And these were not your hacky NLP hacks all over to get the right.
This was not, scikit-learn or any of that stuff, which I also played with that. A lot of, all these forests of those kind of models and XGBoost and all that stuff. And this was like something completely different. And honestly, I sort of, the first time when I saw it like summarizing the excerpt, I think I was blown away right then. I was like, that to me was like what the hell is this? And I've spent enough time in computers, so I've built like every part of every stack from like, low level C stuff to pretty much like, everything. And also, the time that's where I was like, what next? Because I had sort of, I like getting new experiences and learning new things. And I didn't know, like, there was almost at that point, I think you could show me like any sort of software, like kernel stuff or whatever, and I could sort of know how to build it. Given enough time and resources, I figured out. But like this was like alien to me. Like where I was trying to look under the hood, I was like, where's the if, then else statements? Where are the for loops? Like, what the hell is this? Like, what are these files?
There's a new paradigm altogether.
And there's these like files with like floating point numbers. How the hell are they summarizing stuff? I just like it was.
It's all
I
new.
didn't know what was going on, so I was like, okay, I obviously need to figure this out. But at the same time, I started using it and started learning it at that level, sort of like the application level of it. And at a point, I realized there was a lot of like scaffolding I needed. So I started building out that scaffolding, which, long story short, sort of ended up becoming early versions of AX. And by then, along the way, ChatGPT and better models came out, and a whole bunch of stuff happened. Even there were like these sentence transformers, and there was this library called setfit. You could use like even like few examples. You could like tune a classification head or whatever. AX wasn't called AX, was called, I forget, Minds.js or something. I was reading like Culture, the
Got
series
it.
then, and
Okay.
it was like those, the alien ships are AI ships and they're called Minds. So, and I was like sort of putting these scaffolding in place to help me like work with these things. And I got far, and then, anyways, let me shift focus from there back to like modern day, sort of like when like GPTs started coming out. And I was like, you know what? This essentially is a text in, text out sort of interface.
Mm-hmm.
No matter what the API, I think I could like abstract this out because I was seeing many providers out there and all of that stuff was happening. So my main goal was let's first abstract this out so I have like full control over it. I don't want to deal with individual libraries built by these providers. Early on, they were really buggy and all of
Yeah.
this stuff, So my goal was to like scaffold it because this was like the first collection of APIs which could be abstracted. There was
Mm-hmm.
no lock-in other than the quality of the model.
And just
So yeah,
to be sure, like I'm getting the context right, you're talking about which set of APIs? Are you talking about like the open?
I'm talking
Uh,
about hosted models at this point.
okay,
Yeah.
okay, okay. Got it. Okay.
There was OpenAI, there was like
Yeah,
something in
yeah.
Europe, there was Alpha, something. There were like a whole bunch of them. Sure, yeah, but there were actually a few more. Like, I don't even remember what the early ones were. I think there was Google had some. Google had some early ones. So I mean, this was I think GPT like 3, 4-ish.
Okay. Two and a
Yeah,
half years, 3 years ago, almost.
yeah, around there. And then I started to like abstract these things, and at that point I was like, okay, let's like, and that worked well. And I had like a good library. You could talk to any of these things. You get automatic retry and all these, basic
Yeah,
like
basic stuff. Yeah.
capabilities you need like in a
Right.
production grade thing, metrics and all that. And then I sort of like reached the next level, which was like prompting. And I was like, okay, you know what? It's like kind of weird to have these like blobs of text in my code.
Right. Yeah, yeah. I
So
mean, the early LangChain days for everyone of templatizing prompts and substituting variables and kind of.
exactly. So I was like trying things. I was like, okay, I saw someone build some React-like thing to create like a reactive template, and then I saw all kinds of stuff, and they were like, and I just somehow never liked any of them. So and then I think around the time I stumbled into the DSPY papers, like just again because I was so hooked onto archive through my
Correct.
thing, I saw
Yeah,
like the
yeah.
early papers drop, so I started read them, and I think what really just like what out of the box hit me was the concept of signatures. So the concept of signatures converted prompts into this like familiar input output
Yeah,
functional interface for me, and
correct.
and I was like, oh, this is such a like it's a simple concept, but it's like it like changes the paradigm because it sort of like takes this alien concept and makes it familiar to the rest of the system.
System. Yeah,
And
yeah,
I can use all of the compositional capabilities and knowledge I have. And so I was like, you know what, this sort of works for me. So I just sort of focused on that, and I realized, okay, I need type, I need and there is a lot of engineering in there because there is like the whole layer, most of these things are streaming. And early
yeah,
on
yeah,
too,
yeah, absolutely.
I was streaming systems, so I needed
Correct.
them to be able to. What's the point of streaming if you're not going to leverage things like early fail and sorry, you should be able to validate the stuff. You should be able to like not consume more tokens than you need.
Correct.
So I liked a lot of the things that the way early DSPY was doing stuff. Like for example, the way they converted the signature names into like these key value pairs.
Key value pairs. Yeah,
I
yeah.
mean, they've changed since then, but I really liked it because it was sort of like it mapped into the auto regressive nature of models. Because, if you played, like I played with like the non-fine-tuned models, like, these whole,
Yeah.
before the instruct-tuned, as they call them, before the instruct-tuned
Right.
models came out, there were like raw models where
Mhm.
they would complete whatever you gave them. A cat with a hat, blah, blah, blah. It's not, you can ask it questions or anything.
Questions. Yeah.
So that capability, that like fundamental nature of models still exists. It's like it's in the
Yeah.
model. To me, like being able to like have these key values are sort of like a continuum. And then the way you order these fields, and the fact that you could order these fields, like you could have a
Yeah.
thought
Based
field.
on when they're declared, right?
Exactly. So you could have like a thought field, right? The thought field would then force the model to autocomplete the thought. So, and now by the time it reaches the answer field, what has happened? It has added the thought to the prompt. So it is at that point, it's like in the pre-fill state in the LLM, in the inference engine, right? So essentially the answer takes into consideration
The
thought.
thought. Yeah.
Like this was one of the examples DSPY had. They had a signature. They were like, here, you can take any signature and then insert a field into it. And now you have a COT signature.
Signature. Yeah.
So that was one of their examples, and that honestly to me really like was like, wow, this is really cool. And there were no thinking models back then. I mean, you probably don't need that anymore, but back then there was no thinking models, and the ability to just like get the model to output content that then improved the final result.
Yeah.
I mean, it doesn't have to just be thought to be some structured fields too. The fact that you could get it to generate fields you don't need before the fields you need to help the fields you need be better, of a higher quality.
And these were days when there was high error rate in terms of conversion of data back to the data types and whatnot. So
I mean, that's I'm still not a fan of those. I'm still not a fan of structured outputs. I think they're still not there. I'm still a fan of like essentially. I think what does the key value format really let you do? It lets you use the smallest models you need. Sure, you could throw the biggest, slowest models at anything, and you'd potentially, after a couple of error retries, you'd get it right. But you could get small models giving you the right answer every single time. 100x faster and cheaper.
Yeah. I mean, DeepSeek and Mistral, they have kind of proved it that smaller models not only have a place, but as of now, most of the Y Combinator startups are also using and self-hosting some of them, which have high sort of inference cost, have started hosting some of these Chinese created small language models. And
well, they're self-hosting or they're using a provider like Together AI who hosts it for them, who has really good inference engines. So yeah, I mean, even beyond that, right? I mean, I think people can, even if you're using like a small hosted model directly from Gemini, like using Gemini Lite, right? Like, whatever, like the cheapest, simplest version of it. Like the fact that you try to get it to do structured outputs and all this stuff.
But it works fine now, these days, at least. Like a year ago,
so
there were quite a bit of challenges.
The way I look at a lot of these models is that models have finite budgets for things. So it has finite task budgets. So this is an abstract concept, but the idea is that everything you ask the model to do is a task you're putting on the model. It's going to take away from something else. There are only so many, bits that those floating points can hold. So when you're putting more and more tasks on it, it's going to push some stuff out. Within the attention mechanism.
And this sort of percolates as like some sort of context rot or.
Yeah. So what is the like the main key of DSPY that I really like, right? Like the fundamental understanding, like to me, was like what were people doing early on? They would just take a model and say, do this, and give me the answer. Correct. But the idea of DSPY that I really liked, and why did they do that? Because a lot of times people are scared to reach for models in their code. So when they reach for them, they're like, let's do everything. And then give me an answer. But like the idea behind AX always was, I want people to reach for a model like they reach for a function. Correct. So you want to lowercase something, reach for a model. I'm joking, but yeah. You want to like figure something else out, reach for a model. You want to do like, don't like break your tasks down into hundreds of model calls.
And pipelines and effectively
create pipelines. They could just be like, call them like functions within your code. Doesn't matter, right? And like what does that take? That takes you to, it takes some bit of effort to think about your problem as functions and break it down, like
Correct.
you want use a model to classify. Then you use a model based on that classification answer. You use 2 different DSPY signatures to do two
Correct.
different
Two
extractions
different exercises.
and stuff like that. Or if you have like 10 things to extract, then you sort of like, spin it out and extract those 10 things in like a separate parallel
Yeah, I mean,
way.
it makes it more maintainable. A lot more people can contribute and just focus on the parts that they need to contribute on. And as long as
And
if
also use them. They use LLMs a lot more, right? And so when you do this, you're kind of making these models do one single task, and you want them to do it really well. So if you ask these models to also do JSON, that's another heavy task you're adding on top of the model.
yeah, but
JSON,
go ahead.
yeah, I mean, and JSON has a lot of limitations. For one, it's not easy to parse while streaming. So you're going to have to wait for the whole JSON to come
Whole
in.
JSON to come. Yeah, yeah.
And if you don't like a field, now what you got to do? You got to throw away all those expensive tokens, and you got to go back to square one.
Right.
It's not the case with key values, because the second you're generating, you can stop at that point.
This takes
You
me
can
back
error
to
correct and continue on from
continue on from. This takes me back
and
to
that's
the
what
whole,
AX does.
Yeah. This takes me back to the whole XML DOM versus SAX parsing days, right? Wherein people were like, if you got a large file, use an XML SAX parser so that you can continue to, as soon as the what do you call element is completely in, you can parse it and you don't have to wait for the whole sort of document to come in.
Yeah, sure.
Right.
So
Okay. So yeah, go ahead.
yeah. No, so all I was saying is that yes, there is a place for structured parsing.
Mm-hmm.
And it's possible that a lot of people just want these complex nested objects back when you could technically just flatten your object and get it back, because then that would fit in a key value.
Yeah,
And
easy.
yeah, and your model would be faster. If you notice, I don't believe that these models are doing a JSON parsing. I believe they're using a secondary model or something to correct.
Probably.
So
Yeah.
I've seen things being slow. I've seen issues. I've seen things like Anthropic, for example. You're not able to use structured if you're using Vertex. You're not able to use structured if you're using Haiku. So there is like the universal interface is text in, text out, and I believe like the key value text out format is still king. It's going to let your smaller models be smarter and faster.
I get it. Looks like you're someone who would like to the kind of hyped format that's making buzz besides BAML. But anyway, taking a step back, so you kind of discovered DSPy, and you already had a library, right, at that point of time, and you felt that this is a right extension from a prompt engineering perspective.
Yes.
And then you kind of
and just the whole user experience of the library, honestly.
Yeah. Oh, I think Omar was years ahead of others in terms of visualizing how to structure the entire context and prompt engineering in terms of
Yes,
the APIs.
completely.
Okay, so I think I have a sense of where you came from, how you discovered DSPy and the entire journey, and it kind of now all makes sense and looks pretty organic how AX-XML came into picture. And I've got a question for you, which is Python and TypeScript are poles apart in terms of not as much as like a C++ or a Python, but one focuses, at least when it comes to type handling and error handling, right? You have all these compile time errors being thrown in TypeScript up front, and obviously Python is most of it is at runtime. You can do static typing, but when you were looking at that code base and the signature, how did it evolve? Like, did you just look at the high level design and said, okay, I'm going to go and code, or would you were you like I've looked at?
Yeah, no, it's a great question. I sort of struggled with it because I first looked at what they were doing, and when I looked at DSPY, the code base, I think it was really early. There was no types or any of that stuff on it, and so
it's still 50-50, like not even 50, maybe, I don't know, it's not there.
Yeah. I mean, I think they're using libraries like I'm not super familiar, Pydantic or something now to do all kinds of stuff. So I just kept it simple. Initially, I didn't have types. I just sort of went with the string signature. I wrote like a parser for it and essentially went with that. There's some really cool ideas in the Python thing where a function, you just define a Python function, you could convert that into a signature. I think that was there even early on. And you couldn't do that in TypeScript. TypeScript didn't have that. I would have to use some code gen step somewhere else. And I didn't want to get that. I thought the string signature was fine because, I was sort of getting into it. And at that point, obviously, I wanted to map it to the types. And so I started to say, okay, you know what, let me just do validation early on because I needed it. I was using this library. I think the best way to write any library is you should be using it. So, like I was using it. So I started adding things as I needed, like validation. I thought it didn't need everything. It needed certain specific things. I needed like date. It needed
a couple of other things I've seen in the doc that you've provided.
But like the input output types, I still couldn't, I didn't know TypeScript well enough. Honestly, even today, I wouldn't say I'm a TypeScript expert. So I did not TypeScript can get crazy. And, I sometimes, so I didn't even know that I could actually, I actually had forced you to define a type as an input type and output type in the generic, but the signature was still separate. So you could have a mismatch.
Got it.
Because now LLMs have helped me write better TypeScript, and now I can actually take that string signature, infer a type from it. So I did not know TypeScript could even do that. Runtime, parse a string, and build I didn't know it could do that. I don't even look at that code. I just let whatever, Gemini 3 or whatever deal with it.
Got it.
So, but now, things have changed. I've also sort of realized that there are some limitations in that string sort of parse thing, and I moved to a Fluent API. If you've seen the new one, it's the F.
Yeah, I've seen that.
So function.input. Yeah. And end of the day, I just needed a simple way for people to just define the signature. String is supported, but if you want to do something crazy, we don't.
Yeah.
Because early on, I thought that LLMs could write the signature, so it's better to be a string. But LLMs have gotten so good at writing code that it doesn't matter.
All you need to do is perhaps parse a LLM txt file of AX-LLM with all the thing and start picking up.
And that's on our website. If you go on, AX, we have llm.txt, which is the whole site.
That. Yeah, I saw that. So before this interview, I was revising my TypeScript just to sort of. And I think the Fluent API is the one that I would personally pick up.
Yeah. I agree. I use it all the time now. So in fact, now I have something I hadn't added for a long time, the structured outputs. And the Fluent API really helped me add objects and arrays and stuff and it took a while because I actually wanted to have streaming validation even with JSON. So as the JSON was streaming in, it still validated it.
Okay.
So if it didn't match what you were expecting one of the fields, it would stop and restart.
This is after the entire JSON has streamed or midway?
Midway. As it's streaming in, we parse it.
So let's say if you got a dense nested JSON and let's say it's somewhere in what do you call at let's say fourth level, and there are 5 fields that make up the fourth level and only 3 have come in and now you're waiting for the response. So at this point of time, if
it's parsed all the fields that have come in.
Yeah, okay.
And try to map, and they try to see if they match any constraints you have. For example, if you've said I only need this word like hello or bye.
Okay. So you're just doing granular checks, but at the same time you wouldn't say that okay, user info has 5 fields, only 3 have come, let me lay as an exception. You wouldn't do that because you're still.
I wouldn't know if there are more fields coming.
Exactly.
But yes, if the object gets closed and there's another object and the last object is missing fields, it would throw an error. Yeah. And there is some other interesting things I'm trying to do where I get the model to actually just output the next JSON minus the successful fields. So a lot of this stuff is, what really makes a library production or not, because if you're actually running something at scale and you're having millions of requests coming in, these tokens really matter.
It matters. So I'll add to this. I have a LinkedIn post wherein through OpenRouter I got access to MinMax M2. And I ran an entire workflow, which collectively was almost 158, 160 million tokens. And there was a 6.2% error overall. And a significant percentage of that 6.2 was essentially JSONs coming without certain fields missing. And all I had to do, if I do a retry, it would just fix it. But so I completely second what you're saying, that at scale, these things.
Tell me one thing. So these models, are they hosted by OpenRouter or OpenRouter, right? Is that how you got it?
Yeah, through
The
OpenRouter. So OpenRouter has
This is an open source model, right? Yeah, the one you
no, no, no,
mentioned.
no. OpenRouter is like a,
No, the one
project.
you mentioned, the model you talked about. Kinito, is
MinMax
that? Well, min-max.
M2. It's hosted. The company is located in Singapore, but I think it's a Chinese.
Oh, I see. It's a closed model, but you use it through
No,
OpenRouter.
no, I don't think MinMax M2 is closed. I'm not sure about that nature. I
Okay,
was just happy to get free access and get my entire.
nice.
So
How
that's
was
where,
it?
sorry?
How was the model?
It was pretty good. It was pretty good because I ran the same workload on 4 or 6 months ago on Google 1.5 Lite, right?
Okay.
Flash model. And although it's an apple to orange comparison because of the time span that's gone between these two models, but it did better than the Google model. However, latency wise, Google was much faster. These guys were comparatively slower. But yeah, I mean, I can't complain. I got all of it done for free. So yeah,
That is cool.
but yeah. Okay, so moving further, one of the things I want to ask you about is that as someone who's maintaining an active port, and by all means, you're keeping up with the Joneses in terms of all the optimizers that's coming out and everything. As someone who's
We haven't
maintaining,
talked about optimizers at all.
yeah,
It's a DSPY talk.
yeah,
So,
I mean, we'll get there. So, in fact,
okay.
that's one of the next questions. What I wanted to understand, and this question is essentially for those who want to maintain a port or want to port themselves. How do you keep a track of what's happening? How do you catch up on the roadmap? Like how has it evolved? And are you in touch with anybody from the DSPy Python coders in terms of deciding like if there's something you want to understand? Yeah, go ahead.
So essentially, I think Omar has always been super gracious. He signal boosts
Hmm.
AX all the time, and he calls it
Yeah,
the unofficial official. Like, I mean, he sort of said it could be the official TypeScript
yeah,
implementation.
I think it should be.
I mean, sure, but honestly, I think beyond, like, I read all the papers from the Stanford NLP group that sort of do things around here for ideas. I read the papers that come out around the new optimizers and stuff, but I don't think I keep up with like the DSPY Python
Okay.
implementation. I have spoken to some people, like when they were working on DSPY 3, there were some of the ideas we had built in AX that they were interested
Mhm.
in. Like,
Okay.
uh, for example, we had multimodal DSPY.
Yeah, yeah.
So,
AX has that, right? Yeah, for
so,
image.
so that was early on. That was an interesting idea. We had several things that I don't even remember now. I think that I was maybe I just had more time to focus on the thing, and everyone else they were more busy with other important things, real
Do, do
important
you do,
things.
you- do you keep an eye on the issues that are coming in and the enhancement
Not
requests?
in the Python, not in the Python, no, because it's not. I like people. I don't know what to call it. It's an implementation
Hmm.
of the DSPY ideas. When I see, but it's mostly evolving according to my needs.
Got it. Understood.
Yeah.
Okay. This is
So
a pretty sort of mind opening because I always thought that people would want to just keep a very tight check on what's happening so that they can kind of sort of keep up with the Joneses in terms of but I see where you're coming from, and I think it
I
is.
mean, there is no. It's not like anyone really. It's not like one day people have like an implementation in TypeScript and they decide they
Yeah,
need to
yeah,
migrate
exactly.
to
Nobody's
Python and they move back.
yeah,
No
yeah,
one's gonna do
gonna
that,
do that.
right? It's
Yeah, yeah, nobody's
it's like those people
unless somebody's
who try to use an ORM to
yeah,
like
yeah.
replace their database. They never replace their
Eh,
database.
no, no, I completely
So,
agree. Yeah,
and the
unless
idea,
somebody's got
my motivation, my number one goal was just to like, I think, to build more abstractions on top. So and obviously have a very solid foundation. So I wanted it to be really production ready. For example, there's a lot of tracing built in, open metrics. It sprouts a lot of metrics, a
Mhm.
lot of detail counters, and all these things.
Okay,
It's,
okay,
it has no dependencies because I'm really scared of dependencies in your
yeah,
JavaScript world. So
correct.
it has no dependencies. All the
Understood.
API implementations are custom. There is an abstraction layer on everything. So like now a lot of these models for a lot of these LLMs have a concept called token budgets
Right, right. Yeah,
and refusals and max token
Maxwell.
errors. So all of those are standardized in an abstraction layer in AX.
AX.
So
Got
it
it.
doesn't matter what you have below, those token budgets and everything will still apply.
Got it.
So
Got it.
so it's sort of like, I like to think of it sort of like Apple. It's like vertically integrated completely.
Got it.
And
Got it.
so I have like full control on it, and it runs like I've managed to make it run in the browser. If you look at the website, we have an entire playground.
Yeah, I saw that.
That uses a client-side model, web LLM that loads in your browser, and the DSPY runs in your browser. So you're
Correct.
essentially, it's edge DSPY, if you want to call it that.
SDSP.
Or it runs on Node.js, so it's independent of, recently there have been people who've been talking about wanting to put like Zod and stuff in there. I'm still not that comfortable putting any sort of dependency because I don't feel we really need it.
No, I think it's
But
an advantage not to have dependency. So one thing I wanted to sort of dig deep based on the follow-up. So let's say when Mipro V2 paper came out, the implementation came out, GEPA came out. So let's assume hypothetical that tomorrow there's a new optimizer that comes in, right? That's all the rage. What's your approach? You go read the paper first, then you read the Python code, or you just read the paper and you start implementing in AX? How does that happen?
So I've been sort of lucky. I think there are contributors who are quite excited by those pieces. Mipro was sort of started by me. I realized there was a part of it that needed to extract out because the Python hyperparameter optimizer, there's a library in Python that's unmatched. You can talk to GPUs and stuff. I can't do that in TypeScript.
Got it.
So I sort of spun that out. That's also in there. You can like run it. And then the Mipro, by then, JEPA was out. And people are really saying good things about it. So someone else contributed a JEPA implementation.
Okay.
Soon, the same person contributed an ACE implementation. Have you heard of ACE? That's even newer.
Just one second, I'll just go back. So I took it off. So how does that work? Like you have a bunch of folks who are on the Discord or Slack group.
Yeah.
And do you make a call out for somebody to implement, or somebody just comes in?
I don't. So people reach out, they DM me, or they, either on Discord, or they'll open an issue, or they will DM me on Twitter, and they'll start chatting about something, and they'll be like, hey, I want to build this, or I have built this internally. Do you want me to share it?
Oh, wow.
Or they're like, I have this idea, I don't want to waste my time. Are you interested in merging? I was like, yeah, if it's good, I'm happy to merge it, if it's useful to people.
Got it.
These are my constraints that you have to build it in, and or some people just like I'm I love AX, but I saw you guys didn't have this ACE optimizer that we're using, and let me just I built it, I'm using it internally, I would like to merge it. I think honestly, even for them, their approach is probably putting a paper in an LLM and just asking for the code to be written.
Yeah. Personally, I don't get 90% of the math that's in there. So
they probably tell the LLM to ignore it as well.
Yeah, that's what I do, and I just ask it to dumb down and explain it to me, and then if I don't get certain parts, dumb it down further, then sort of start going above, and then finally sometimes I dig into the paper, and things make more sense. Yeah.
And end of the day, a lot of times these papers don't have all the details. You really have to start working with an implementation to get something right.
Correct.
So it's you can implement it, but then you'll realize that there are 50 things missing, and you really have to start using it yourself, and then realize it's sort of missing stuff. So
okay, so this was pretty helpful. Just understanding how you are porting the various optimizers. So now, so we are down to the last two questions. Has it ever come across, any idea has come across you which is not there in DSPy? Or like, for example, maybe like let's take, for example, summarizer or middleware that LangChain sort of has now, right? LangChain has this whole concept of middleware, and then you have the prompt and the data sort of passing through each, and you decide to apply. So for example, let's say if you ever encounter something which is not in DSPy, it's a complete idea coming from outside. How do you approach that as a maintainer of a port? Like, do you say, okay, hey, I think this is helpful, I'm going to go and implement it, or you say, hey, you know what, this will make things quite different than how DSPy handles it. So how does that happen? And
I think honestly, I'm open to any idea. That's the thing. This is just software. Worst case, I'll take it out and change the major number and say this is a breaking change. You know, I mean, yes, obviously I will not because it's production code where, we take version numbers and stuff quite seriously. We don't break anything. But at the same time, it's a small project. I'd rather have code moving fast and experimenting with things than to, sort of, stagnate or code is not changing, it's sort of dying, and these days it's even more. But the thing is that about ideas, I think the ideas, the ones I pick are stuff that someone has contributed because it's really useful to them. And I sort of see it, or it's something I need, or I might not use it, but it's an idea I've been sort of playing with. For example, there is stuff in there, like there is a whole like I mentioned early on that I like to build abstractions. So I started with the abstracting the thing that I thought of DSPY as way of abstracting the prompt. Then there's a concept in DSPY called the DSPY program. I know. What is that? If you look at it, it's a class in Python which has multiple signatures inside, and you sort of register them, and then they will all sort of, they'll all get optimized together, right?
Together, yeah.
So I was thinking more on that, and I thought of that as more like a computational graph, and that's made up of signatures and stuff in the nodes. So, and I looked at a lot of the programs that I had built and how, and some of the things I needed within it, like what if I represent them as a computational graph? What are the nodes I need? And then I built another abstraction on top called AX-Flow.
Okay.
So if you look at AX-Flow, it's on the AX-LLM.dev website. Okay,
I've missed that. But if you can speak.
So if you go right up to learn, you'll see it says there is AX-Flow. AX-Flow is a concept where you can define these sort of graphs with nodes, which are signatures. And then you could have those nodes work with data from each other. And you could build these like sort of programs.
Got it. Understood now. Yeah, I'm seeing it right
now. And there's a lot of like automatic optimization. So there's a engine inside that will figure out the dependencies and stuff. It will make parallel calls where it needs to. It'll make serial calls where it needs to. It has many specialized nodes. And the next abstraction that I'm sort of building on that is I'm actually trying to tune a model to understand AX flows. So then you could generate sort of like entire AX programs on the fly.
So we have all these planners and breaking things into to-do list, etc. I think something like that can map onto an AX flow kind of. It'll be linear, but yeah, I think
like our entire we have something called AX RAG. AX RAG is basically, if you look at it, it's if you go back and learn, and it's nothing but one giant AX flow. So if you scroll down a bit into it, you'll see how it has all the nodes. It does like quality assertion, question decomposition, evidence synthesis, analyzing, refiners. So this is like a deep search RAG here is that it's sort of like whatever data source you want it to, it will like generate questions, query that data source, sort of like synthesize whether judge the quality of the answers, and then make more calls. And so
and each sort of has a type that sort of helps distinguish its
yes, and the whole program itself has a type. The whole program is optimizable, and because we generate like types of inputs and outputs from every program, we also have we automatically convert that into a JSON schema as well if you need it. So all these programs can be functions on other LLMs.
Understood. Got it. Yeah.
So then the LLM can call these flows as they need, because the agentic things are where you have these like function calling. So essentially you can leverage these as functions automatically.
No, this makes a lot of sense. I mean, Claude just came up like I think this last week where it said that, hey, we rather generate the code and then execute it as opposed to injecting all these 100 of tools and what its purposes are. And I think AX flow kind of, and the way you're using types and the fact that you can dump it into a JSON schema and then sort of restructure the whole thing again, might as well give it to an LLM, educate it, and then get it to generate the flows. That's exactly what your mindset is around this, right? Okay,
it's all these systems are very dynamic. So and if you really think about it, a lot of people talk about like bigger models, this and that. Right. I think to me that what's most exciting is how you can get models and you can like inference the hell out of them. You can get outputs of this model going into this model, then being judged by these models, then this model.
That's already happening.
And if you do that, like for five, like, it's a lot more than most people think in LLMs. You ask a question, you get an answer, right? But what if I allowed you like a whole day? I told you you have to have this thing constantly inferencing for a day. What do you get at the end of that, right? It's up to you what you want to do during the day, but you cannot stop, right? Like you can get some powerful stuff.
If that was the proposition, I think having an agent that's able to build a big software by sort of decomposing it into hundreds of tasks, and then sort of validating each steps and go.
I mean, it could be, right? Like a part of it is writing code to solve its problem. Like I know that a lot of the code now is like written, committed into repos and stuff like, but I'm sort of like more of a believer than in like code repos and stuff are going to be just a cache. Most code is ephemeral when LLMs can write it. You can throw it away if you really want to, but you're sort of caching it because every time the LLM is changing your functions and your products and your code is just being like,
yeah, maybe this is what the future is going to be, right? Like we take
it's not human time anymore, right? So it's not the reason. Like if someone is paying me $100 an hour, then they like lock it up in a repo and then be like, oh, this is our code, let's hail to it. How does it matter when the tokens are dirt cheap and they're just like,
yeah, I think what you're saying is definitely the future. And that future could be 3 months down the line, 6 months down the line, a year down the line. So this brings us to the last question, before we kind of wind it up. So I see a lot of new DSPY ports coming in. As a matter of fact, now you have one language having multiple DSPY ports. So assume for a moment if somebody was starting a port in C++ or for that matter in Zig, and it is zero for that person. What are the things, like how should they take this undertaking, and what are the things they shouldn't do?
That's a good question. I think that's a very good question. I think just start off. Don't worry about the fact that now DSPY has become so big and there are so many parts to it and there's so much flexibility and all of that, because that'll just stop you from building it. To me, the most exciting part of DSPY, honestly, is the signature abstraction. Start off focusing on that. Find out how you can make it really idiomatic in your language.
Got it.
The key thing that you should always, like the guiding force, is whatever you're building should be so easy that developers reach for it like they reach for functions and libraries within your language.
Right.
You don't think 5 times before creating a new function.
Right.
But you should design your DSPY library so it's that easy. So that they just it's like hundreds of calls through their code base everywhere. They're able to manage all of them well. Think about the fact that there are certain things that might need to be global, certain things that have to be local. Do you abstract? Do you take the signature out from the execution engine, like we call it an AX-gen, and then you pass a signature into it, and then it so even that abstraction, like it evolved over time. So, and there were reasons for doing that. So the question is, I think, try to keep whatever you're doing very idiomatic. Don't look at the Python library and think that that's let the paper guide you. And the optimizers and stuff, figure that out last.
Got it.
So just get people in your thing comfortable using an LLM. That's it.
Got it. So basically, get the basics right. Be a first-class citizen of the language that you're coding in, so that people get it intuitively off the bat as they pick up the library, and
make it so that they want to use it everywhere, right? Don't like make it complicated for them.
Got it. So Vikram,
I think haven't we covered all languages by DSPY? Is there one left? Is anyone going to write another one?
I think there are quite a bit of languages that don't have a port as of now.
Oh, really? Okay.
The top 10 ones do.
I saw closure ports, so I was like, okay, maybe.
In fact, he'll be on the show on 15th, and Kapil, and he's based out of Pune, and he's the author of the port. Yeah. So Vikram, thanks for doing this real early morning at your place, and it was fun hosting you, and I'm sure a lot of AX fans would love to just hear you out and watch this episode. And a lot of those who are writing ports would also love to hear you. And those who are into TypeScript at some point would surely watch this. So thanks a lot for doing this. And
thanks. It was a lot of fun talking to you.
Thank you. I'm going to end the Recording.
Sure. Yes.